So in this problem, we want to find these partial derivatives. So f(x)(x), that means we'll differentiate with respect to x twice. F(y)(y) means with respect to y twice. This is, of course, just z once. And this means with respect to z and then y. So first, let's find the first three first-order partial derivatives, which is just f sub x, f sub y, and f sub z. So when we differentiate this with respect to x, we're going to treat y and z as if they're just constants. So the derivative of 6x squared is just like normal, 12x. Now there are no x's here, so with respect to x, y and z are constants, so that derivative is 0. And the same thing here, the derivative of 4z cubed is also 0. Okay, next let's take fy. So the derivative of 6x squared is 0 with respect to y. With respect to with respect to y, the 3 and the z are both like constants with respect to y. So it actually might even help to think of this as 3z times y, because the 3z, we sort of treat it like it's the coefficient of y in this case, because we treat z like a constant. So the derivative of that term is 3z. And then the derivative of 4z squared with respect to y, there's no y, so that one's 0. And then f sub z, derivative of the first term is 0. Of the second term, 3y is the coefficient of z, so the derivative of that term is 3y. And the derivative of 4z cubed is 12z squared. So that's actually that one right there for c. Now for the other three, for f(x)(x), we're going to differentiate fx right here, again with respect to x. So the derivative of 12x is just 12. And fyy, the derivative, we'll differentiate this with respect to y. Well, there are no y's here, so its derivative is just 0. And for fzy, that means take this partial right here. First, we differentiate it with respect to z, then y. So differentiating this with respect to y, the derivative of 3y is 3, and the derivative of 12z squared is 0.